All right, so I've done the first sentence, right? The first four non-zero terms for f prime of t squared. All right, if g of x is the integral from 0 to x of f prime of t squared, use the first two non-zero terms of the Maclaurin series for g to approximate g of 1. Well, it's asking us to use g to do something. So let's write out what g is. Well, technically, to create g, what I would do is I would integrate f prime of t squared, which would be in terms of t, and then I would plug in the x minus plug in the 0. But that's going to end up just being the integral of f prime of t squared, but having x's in it. So if you integrate 3t to the fourth, what do you get? 3/5 t to the fifth, but if I replace it with the x, it would be 3/5 x to the fifth. Minus 3/11 x to the 11th. Plus 3/17 x to the 17th. 3/17, sorry. Minus 3/23 t to the 23rd. X, thank you. All right, so now use the first two non-zero terms of the Maclaurin series for g to approximate g of 1. So what are they wanting us to do? Plug a 1 into the first two terms. So make sure you use your approximate symbol. So g of 1 is approximately 3/5 minus 3/11. Yes, you may stop there.
Did you really have to find all four terms?
No, we didn't really need to find all four terms. I just kind of got carried away. All right, so have we done everything that Part C has asked for? Yes. All right, looked really scary, but not too bad. All right, Part D. Lots more words. The Maclaurin series for g, evaluated at x equal 1, so that means if I continued this infinite series at g and plugged in a 1, is a convergent alternating series with individual terms that decrease in absolute value to 0. If they talk about an alternating series, they're usually going to tack on that with individual terms that decrease in absolute value to 0. So basically all that's saying is that the reason that it's converging is because the terms are decreasing and the limit of the nth term is 0. So it's wordy, but they're probably going to throw it in there. So they're just saying that this is an alternating series. Show that your approximation in Part C must differ from g of 1 by less than 1/5. So it's basically saying, convince us that the error that's associated with that approximation is less than 1/5. Well, we've learned two types of errors, and that's the only two types we're going to learn. One is the Lagrange error, and the other is the error for an alternating series, which that is an alternating series, so you want to definitely use that one as opposed to the Lagrange, because it's easier. So what is the whole concept behind error on the alternating series? Your error is always less than or equal to what? The next term, the absolute value of the next term. So in this case, your error has to be less than or equal to what? What's the next term that I didn't use in g of x? Evaluated at x equal 1 would be 3/17. Now, they also, and they like to kind of throw this last part in here, that the error is less than 1/5. Is 3/17 less than 1/5? Yeah, why? Yeah. Because 1/5 is the same thing as 3/15, and 3/17 is less than 3/15. All right, so that alternating series error is usually asked like this, where you just have to identify that the error is less than or equal to the absolute value of that first neglected term. And that is all you need to know to make a 5 on the calculus exam. That and everything I've taught you from day 1 since August.